Okay, so this is 2016 question B1. So it's the dihedral angle basically intersecting surfaces. The image on the right shows a restaurant which consists of a series of intersecting triangular glass surfaces. Figure B1 shows the plan and elevation of 4 such intersecting planes. Data related to the horizontal vertical coordinates for points A, B, C, D, E and F. Defining the 4 planes are given. So look here, notice there's a missing one for F. Part A, draw the given plan of the 4 triangular planes and, so draw the given plan of the 4 triangular planes and complete the elevation of the intersecting planes ABC, ABD, DEB. So they're not asking for DEF, common pitfall for students. Part B, determine the dihedral angle between the planes ABC, ABD. Part C, draw the given elevation and plan of, I'll get to part C later, so I'll just get going here. So we can draw in our XY line. Okay, we can draw in our YY line. Okay, so A is over 130 from the YY line, B is over 160, C is over 100, okay, D is over 180, E is over 210, okay, F is on over 230. Okay, so now A is up 40 for its Y coordinate. So, oh sorry, that was C there. So C was 85. So there's C for its Y coordinate, and then for its Z coordinate it's down 35. Now A then was up 40 for its Y coordinate, and then it was down 80 for its Z coordinate. Okay, B is up 85 for its Y coordinate, okay, and then down 35 for its Z coordinate. Okay, D, the next one, is up 30 for its Y coordinate, so just, I know you can't see there, but there's the coordinates there. Alright, now D is down 75 from the XY line for its Z coordinate. E is down 25 for its Z coordinate. Okay, and it's up 70 for its Y coordinate, up 70. Okay, F then, we don't know the F coordinate for, we do not know the value of the Y coordinate for F, but we do know it's down 55 in plan. So there's F. Now we can connect these together as per the diagram, the plan elevation. E to C, A to C, C to B, B to C, B to D, D to A, D to E, and E to B. Now we have to find, there's part A done. Part B, determine the dihedral angle between planes ABC and ABD. So I'm going to pause the video, colour them to highlight them and show them to you. Right, so I have those two surfaces coloured. Now, in order to find the angle between them, I need to see the line of intersection as a point. So if I want to see the angle between two surfaces, okay, you need to see the line of intersection as a point, like this. Now when you see the pencil as a point, the set square appears edges, and then you get the angle between them. In order to see a line as a point, you need to look along its true length. Now this is so critical, along its true length. So many students just look along the line of intersection. It has to be the line of intersection's true length. So the line of intersection is AB. Now line AB is not a true length already, because it's not parallel to the XY line in plan, so it's not a true length in elevation then. And it's not parallel to the XY line in elevation, so it's not a true length in plan. So I'm going to look perpendicular to the line of intersection AB to get its true length. Alright, so we're going to line our set square up with line AB. And we're going to draw lines perpendicular to that. Right. So I'll extend them on. Now, so this type of auxiliary is an auxiliary elevation. So we're going to take oh, I need to do that again. So we're going to draw on our x1, y1 line perpendicular to these here. Now I'm just going to move the visualizer across. So our x1, y1 line is going to be perpendicular to this. Okay, and we're going to take our heights from elevation. So I'm going to use a datum line here to save space, right? So datum line there. Now, so I'm going to take my heights from here. Okay, so my compass on A. So lift my compass. I'm going to find A over here. Follow it along, mark in A. I want to do it with C, so compass, it's directly above C. Okay, I'm bringing my compass to it, find C over here, marking C along there. B is going to be the same height. I want to find B, and now I just have to do D. So compass on the datum line, bring your nib to D. And then we can label then. So A1, D1, B1, C1. Now if 2 points join the view, they join in every single view. So A1 is joined to B1. A1 to C1. C1 to B1, B1 to D1, D1 to A1. Now I'm going to pause for a moment and colour those surfaces in. Now if I want to get those angles between those two surfaces, now I need to look along the true length of the line of intersection. So I'm going to look along line A1, B1, D1. So I'm going to project parallel to A1, B1. Now, I now need to, okay, I need to draw in my X2, Y2 line. So, X2, Y2 line. Now, this is going to be an auxiliary plan. And it's also going to be a second auxiliary. So you always go to take the distances from two XY lines back. So 1, 2, back to here. Obviously a massive amount of distance to cover. So what we're going to do is we're going to use a datum line like we done a moment ago to shorten the space required. So a datum. So there we go. Alright. So we're taking that distance from our datum line back. The compass has just moved a little bit. Now, so we're going to bring, that was D, so we're going to go to D1 down along here and mark in there. That's going to be D1. Oh, we're going to take A and B. So look, there's A1, and look, B's the same, so follow B, it's the same. It should be, because line A1, B1 appears as a point. Now, we take from our datum line to C, lift our compass, find C here, and there's C1, or C2 rather, so C2, B2/A2 and D2 there. So they're going to join together. So this is the blue surface and this is the pinkish surface, right? And the dihedral angle is in here. Dihedral angle. Okay, because both surfaces appear as edges. A surface will project as an edge when any line on that surface projects as a point. Now, I would always measure in the dihedral angle, so I'm getting a value of 165 and write in the value. Alright. So the next part of the question, part C. Draw the elevation and plan of a horizontal line on surface DEB and then determine the true inclination of a surface DEB to the horizontal plane. It's literally a dihedral angle question again, really and truly. Okay, but just simplified down. Right, this is surface DEB. Okay, and it says draw the projections of a horizontal line. Draw the elevation and plan of a horizontal line. So I'm going to draw a horizontal line here. I'm going to call that number 1. So I want to find the plan view of that line. So I'm going to drop 1 down to here. Now 1 joins to E in elevation, so it joins to E in plan. So that's exactly what I'm going to do. I'm going to join E to 1. Okay. Now if you look along the true length of a line, it projects as a point. Line E to 1 is a true length in plan because it's parallel to the XY line in elevation. So if I look along line E1 in plan, it's going to project as a point. Alright, it's going to project as a point. Alright, and then the surface that it rests on, DEB, is going to appear as an edge. Right, so, and the reason I'm going to project along the line from plan is because an auxiliary elevation, it'll give me the x1 y1 line in an auxiliary elevation is an edge of the horizontal plane. So I'm going to look along line E1. I'm going to project perpendicular to that. Here we go. Here's our x1, y1 line. And we're going to take our heights from our elevation. So I'm going to take the height of D. I'm going to put D here. I'm going to take the height of E. Lift my compass, find E here. There. I'm going to do the same with B. So B. I'm going to do the same with number 1. And look, it rests in the same place as E. So it does. So this is 1/E. This is B1. And this is D1. So all three of these join together. So here's an edge of the surface, and if I continue it down, the x1, y1 line, here's the true inclination, because the horizontal plane appears as an edge, and the surface DEB is an edge. So there's the true inclination of the surface to the horizontal plane. That's another way of being asked to find the strike and dip of the surface. Another way. Look, level line, horizontal line. It's a strike, that line. It's a strike. It's the dip. It's appearing as an edge. Another way of asking it. Right. Next part, I'm just going to colour them in to get started on it. So I'll pause, colour it, and get going on it. So the next part, surface DE and F and DE and B share a dihedral angle of 170 degrees. Complete the projections of DEF. So drawn in elevation. So it's awkward here because we don't have a height and elevation to complete this, but we're going to execute it as we would as normal. Right, I'll just move the visualizer here. So if I wanted to see the dihedral angle between these two surfaces, I need to see its line of intersection as a point. And the line, in order to see a line as a point, you need to look along its true length. This line is not a true length in plan because it's not parallel to the XY line in elevation. It's not a true length in elevation because it's not parallel to the XY line in plan. So I'm going to look perpendicular to this and see its true length. I'm going to draw in an x2, y2 line or an x1, y1 line rather here. And I'm not going to use my datum line there. I'm not going to use it anymore. Alright, because I need to get F, right? So I'm going to take the height of B and I'm going to put it along B there. I'm going to take the height of D. I'm going to put it along D. I'm going to take the height of E. I'm going to put it along E. Now, I have no height for F. There's nothing I can do about it. So this is D1, B1, E1. Right, now this is the line of intersection as a true length, LOI as a true length. So if I wanted to see the dihedral angle, what I do now is look along that line of intersection. So I'm going to look along that there. It's our X2, Y2 line. And to get the points here, what I would do is go 2 XY lines back. So I'll go from, I'll do a datum line here. So if I wanted to get D, I go from my datum line back to D, lift, follow D here. So D and E there appears the point, and then if I want to get B, there's B. So I'm going to follow B along there and mark it in there. So there's surface DEB. B2, E2/2. Now it says the angle is 170 degrees. So I'm going to apply the dihedral angle here of 170 degrees. So I'm going to mark in 170 this way. And it's also possible it's going that way. That it's going the opposite way. So I have two options, option 1, option 2. Now, so somewhere along one of these lines, it lies point F. Okay, it's this surface, it's the finishing of surface DEF. Now, if we had what you call it F, alright, what we would do is we take our distance from our x1 and y1 line back, find F here, and plot it there. We don't have F in this view, but we do know that F should be this distance from the x2, y2 line. So look, what we're going to do is we're going to take the distance of F and we're going to plot it there. So F should be somewhere at this distance from the x2, y2 line. Oh, they moved a little bit. So that's one possible position for F. This is a second possible position for F. So if you could get them here, you can bring them back to there. Alright? So we're going to bring them back. So if I bring them back here and here, F would lie on this view, or on this line coming from F in plan. Now here's two possible, so you could have two possible scenarios. This could be the auxiliary elevation of the surface. That one could be, or this one could be here. Alright, but you only have one practical answer. Okay, it's like a maths question where you can have plus or minus 10 acres in a field for an area in coordinate geometry using the triangle formula. Alright, now this is the height of F in elevation. This is an auxiliary elevation. So if I wanted to get F's height in elevation, I would take, look, I would take this distance. This is one possible option, mark there. This is the second option, so take that distance and mark there. And the practical answer, F, is there. That's the practical answer. So you can join these to get, oh shucks, drew that on the wrong line. Clown. Sorry about that, guys. So as I was saying, you could have two possible answers. So here or here. And you're only going to have one practical answer. It's going to be there. Right. DEB. So that is the question done. So you're working backwards in that one there, and you have two possible answers. Look, you get this surface, you take an auxiliary of this surface here, looking perpendicular to line DEB. Then you look along DEB, you find the surface as an edge, mark your two possible answers of 170 on it. Okay, and then take the distance from your datum line or x1, y1 line back to F with your compass, plot it here, draw a line parallel to the x2, y2 line. It doesn't matter where you plot that distance. Where the parallel line intersects the two options, you have two possible options for the letter. Bring them back perpendicular to your x2, y2 line until they intersect the line coming from F in plan. They give you two possible answers for the height in elevation. So you take your heights, transfer from your auxiliary back here, and you only have one practical answer. So you do. Alright, and that's the question complete. Cheers. Thank you. Oh, need to get that in. Cheers. Thank you. Bye bye.